the Global System Science program that we have developed in the European Commission, which was a follow-up program to a program we developed when I came to the Commission more than 10 years ago, which was a complex system program. So global system science is more or less about applying complex system ideas to policy and society. So I guess the key ingredients here is data, models, and systems, and I will talk in turn about these three issues. In generally speaking, I think it's about what Angel Gurria already said. It's about going from thinking to doing, going from scientific evidence to policies and what I like to call policy narratives, and I will try to explain what I mean by that. There's a couple of drivers, I would say, and they were already mentioned a couple of times. The first is the networking aspect, so everything's connected. If I would have mentioned everything's connected 15 years ago, I would have been probably a visionary. Today, everybody talks about everything's connected, but I claim nobody really draws the conclusion from the fact that everything's connected. And I guess global system science is about drawing conclusions for policy and for academia and science about the consequences of the existence of these various networks. There have always been networks, I think, in humanity. I remember work done in Santa Fe Institute on the Medici network, which made the Medici such a dominant force. They had a network that created, that the network of the Medici was the force of the Medici. I guess the difference today is the scale. Due to information technologies, all these networks are on a totally different scale. Social media creates networks all over the world. Trade networks are partially different today than they were 20 years ago due to information technologies. The web itself, the internet, of course, is the most eminent net that we have today. And as Giorgio Papadimitriou said, one of the computer science gurus of today, he said the internet is the most complex artifact ever created by mankind in absence of any central control. And I guess this is the important aspect here, in absence of any central control. This makes the internet such a special network. And this makes the internet such a difficult thing to make regulation for and to make policy on, because national policies are still national and they do not cope with this global aspect of the internet. So I think the nets, be it the internet or be it the trade networks, create formidable problems of coordination. And I guess coordination problems are at the heart of what we're discussing today, and it is here that systemic approaches can make a difference. There's another aspect from these networks, and I think this is the positive aspect. This is the scalability issues, the opportunities that were created by the fact that we now can collectively, among a large group of people, do things. For example, think of citizen engagement, where citizens collectively map certain aspects, for example, pollution levels in cities, or the history or the carbon footprints of certain products. This is via the use of social media and via the use of the internet that citizens can actively engage in data gathering. So I mentioned already this coordination problem, which is a direct consequence of the various nets that we have. And I would like to mention one aspect which was already mentioned a couple of times, this linearity of thinking, the unbearable linearity of thinking, as I would like to call it. If you think a typical economist, the first thing he learns is these typical demand versus price and offer versus price curves. And where they meet, magically the economy will go to. There's two things in this. First is there is no good reason to assume that these curves are monotonous. And yet, without even presenting it as an assumption, it is presented as monotonous curves. And if they are not, then you have multiple equilibria. This is one issue. The other issue is there's no good reason to assume that the system necessarily goes to the point of equilibrium. And yet in economics, this is standardly assumed that via the famous invisible hand, the system is driven to this equilibrium. I think dynamics is a very clearly absent aspect in many economic theories. In this respect, I think it's very important to have, you pronounce it NIAC, right? Nike. That Nike is developed here in the OECD because OECD is, as Angel Gurria pointed out, is bridging between thinking and doing. And I think NIAC points its hand essentially on this unbearable linearity of thinking in traditional economics. I have to say we have a history with the European Commission and OECD. And in 2007, we had a workshop between OECD, EC, and NSF and the very poetic title is from the Americans, Science of Unintended Consequences and Unrealized Opportunities. I guess this is a very nice way of paraphrasing complex system science. There's another driver, of course, of today's issues, and this is data. Data of all sorts, data from sensors, data from digitization of existing data, but in particular one type of data that we leave as citizens online. So digital traces of human activity. I think this is one of the drivers of a totally new form of social sciences. Social sciences that draw on empirical data, social sciences that can even draw on experiments done online. So social science is becoming, to some extent, an experimental science. And this is something which is very new. So mobility data, social science networks data, wearable sensor data, all kinds of data that we have now and that create this enormous flux and flow of data that we have to cope with. Of course, there is opportunities, as I said, for the social sciences, but there's also threats, right? Think of NSA, surveillance, loss of privacy. So there's always this trade-off between opportunities and threats, in particular here in the area of data. Another issue which comes up, of course, is, it was already mentioned by Vladimir, the increase in speed in computing, I guess. And it is nice to have big data, but you need also big theory, as I would like to call it, so you need models. And I guess the fact that we can now execute models much faster than we could 10 years ago or 20 years ago. I remember when I was a student, I had a state-of-the-art workstation with 33 megahertz. You see, today this iPhone has 1.5 gigahertz. You see, so there's an enormous increase in computing capacity, and this helps, of course, also in dealing with big data. So I think there's three ingredients that make new approaches to policy possible. This is advanced simulation of highly interconnected systems. I think one lesson you learn from complex systems is that systemic properties are determined by interaction and not by the characteristics of the individual components. So interaction-based science, as somebody calls it, Chris Barrett from Virginia Tech, I guess, is the important thing here. You see, interactions dominate behavior. Then big data, of course, I already mentioned, and complex system science, the underpinning concepts of this new type of approaching policy and of approaching science in general. So opportunities are, of course, evidence-based policies, holistic approaches to policies, so going beyond the silo, this was already mentioned, and systemic risk awareness. I think the financial crisis of 2008 clearly showed that the main problem with current economic thinking is a lack of understanding of systemic risk. Risk that is the result of networks that we do not yet know how to manage. Let me make one remark. Of course, as a physicist, I would have a tendency to think about prediction. And prediction is something that determines policies. But I think you have to be very careful if you use the word prediction in the context of social systems. It means something completely different. And I will skip this one. Herb Simon already in the 60s, Herbert Simon is a Nobel Prize in economics. He got his Nobel Prize for work on decision making, but he's also considered the godfather of artificial intelligence. He mentioned something. He said, perhaps we should think of planning as a valuable creative activity in which many members of a community can have the opportunity of participating. So we shouldn't think of blueprints of planning. We shouldn't think of planning based on, let's say, Descartesian approaches, but we should think of planning as a collective effort where we so to speak, as the Chinese put it, we surf on the possible. So we let models guide ourselves in our actions, but we still, construct the reality. And it's not the computers that construct the reality, it's our decisions that construct the reality. It's the narratives that we create. And I think this is a very important difference between a physical system and a social system, that we as humans construct the realities with which we live. And this has to be taken into account in the way we use models in policy. Just this quick historic excursion to computers, I think for a long time artificial intelligence and computers were seen some sort of replacement of human intelligence, and now we understand that computers are more a means of helping us thinking and a means of federating our thinking. I guess this is a very important aspect which came very clear with the work, with the onset of social media. So what I would like to spend the last 2 minutes or so with is this difference between a physical system and a social system. And I think these differences are clearly, as John Searle put it, reality is a social construction. And we should take this idea serious in the way we approach modeling. So how can we understand the underpinning narratives of our actions? There is already some ideas. For example, there's a big program here in France by Bruno Latour who tries to analyze blogs and tries to analyze how narratives are created on blogs. So this is a use of information technologies to better understand the underpinning narratives of our actions. And also, and this is a bit dangerous, of course, to some extent, how we can guide the evolution and the emergence of such narratives. If you think of the Arab Spring, some people say, I'm not claiming this is correct, but there is a rationale in saying so. The Arab Revolution was a Twitter revolution. So it was something where those, at least who were on Twitter, could create their own narratives against the power of the narrative power of the authority, as they call it. I think these aspects should be included in any aspect of social modeling that we think of. If I think of global system science, I think of this triangle. On the one hand, we have mathematics, so the capacity of mathematics to precisely model. As Jonathan Wheeler put it, he talked about the unbelievable efficiency of mathematics to recreate reality. And in physics, it's indeed amazing. If you write down the exact equation, then you can be sure it's a one-to-one correspondence with reality. I don't think that you can extend these ideas to social systems. So it's on the one hand mathematics and reality, big data and models. On the other hand, policy and societal action, and the link between them is of course evidence, but then it's also the social realities that we construct via narratives. And here there has to be a consistency between the models we have and the narratives that we live by, if you wish. And in the center of that, we have the engaged citizen. And I guess this is the core concept of global system science as we have been developing it in the Commission. My last slide, so what? Instead of a conclusion, so what? You see? Everything's connected, so what? I think the main consequence I see is systemic thinking as a new way of doing policy, new forms of coordination. I think we have nowadays no longer problems of scarcity, we have problems of coordination. Big data, so what? I think there's a lot of hype about data. Some American gurus claim correlation supersedes causation, for example. But I think we have to very carefully think about what we do with this data. We think about the opportunities, but also about the threats, and we have to understand that, as I said, big data needs big theory, and I guess this is a very important aspect. And finally, prediction, so what? I think we have to understand that in social systems, there is a trade-off between prediction and the construction of reality via narratives. And I think this is something we have to work on, and this is a start that we have been working on in the last couple of years, and we are at the beginning. But I think this is something we have to understand. I thank you.